Problem 2 and 4 max running time of n computers. N computers. We have n batteries, which can power a computer, whatever. And we want to run all computers simultaneously. You can run all computers simultaneously. Well, I guess we have to have more batteries then. Oh no. Oh no. Okay. Well, that sucks. Okay, so well, I guess we always want to plug the largest two, and we plug them until they are smaller than the largest, right? It's 10 to 9, so sometimes that might take a long time. Really, I couldn't have gotten any other problem than this. Ridiculous. Now you can hear me after 2 minutes of the video. This is stinky problem. Well, you have K computers. Maybe binary search? Maybe binary search. So, because if we can run it then for 4 minutes, we can run them for 3 to 1. And if we cannot run them for 5, we can run them for 6, 7, 8. So now just how to verify that we can keep all of them running why is the max runtime long? Because it can be 10 to 14 if you have one computer and 10 to 5 batteries, each having 10 to 9 capacity, then you can run that single computer for 10 to 14 time. So for that, okay, so can they be run for time k means that I need to run them in a combined time of k times n. I mean, I don't think that it's that simple. That wouldn't be a hard problem then. Because, okay, how do I verify that given these batteries and I want to power that computer for time k, right? That means that I have to be able to power the first computer for time k, which will take this amount from batteries, right? Then I want to power the second computer and so on until we use everything. Let's say we have 3 batteries of, so 2 by 4 is 8 and this is 9. Okay. So let's see, long sum is accumulate batteries, begin batteries, and 0 long. So this is their sum, and then we return n divided by sum, or sorry, sum divided by n. That cannot be right. So for given batteries 10, 10, 3, 5, I said that we can run them for okay, well, let's say we run it first for time 5. We have 3 of them, so we run all of them for time 5, and then all of them for time 3, and we are left with 2. Different idea. We just pick the 3 largest one and we run them to the ground, right? So we sort the batteries. Do I have to do that though? Let's see, if I have like, I don't know, 1000 batteries and 10 computers, then I take first 10, batteries, run them down, which means well, each time I remove 1 from there and it takes me n time. So time complexity will be number of whatever times number of whatever times whatever. I don't know how to simulate that fast. Let's say we go backwards, right? And we say that and we use the like batteries 3, 5, 10, right, for time 3, and then we add like a I don't know, -3 from the next battery, right? So we power them for 3, then we have a 2 whatever and whatever, right? So we have 2 this, so we run it until then, and then blah blah blah. We can move on like that. It should work because 3, 5, 10 is gonna give us 2. Then we have 3, 8, 10, which is gonna give us 3, and then we are cooked because we have only 2 batteries. And okay, it doesn't work like that. Great. I don't know, dude, it's too much time. Okay, binary search. Okay, I knew that. You didn't hint me anything. Maximum runtime of n computers. Maximum running time of n computers. What the hell? What the hell? What the hell? How do I verify that they can run for time k? Well, clearly just checking k times n is not enough. So now that means you have to be able to subtract idea. What if I have like 15 of them? I'm thinking about combining the batteries because ideally, right? Oh shit. Okay, so let's say you want to have let's say there would be, I don't know, 50 batteries, right? Well, what we want, 3 batteries, then we can run down, 3 batteries that we can run down, 3 batteries that we can run down, and blah blah blah, right? So running them down means they are larger than at least k, right? So all batteries that are smaller, how do we want to group them? Because if I have it like a 1 2 1 2 1 2 1 2, how do I group them? 1 2 1 2 1 2 1 2, that's like 12, and then another 1 2 1 2. So how do I group them? So let's say I have like 5 4 3 2 or 5 4 3 1, and I need batteries of 5 or batteries. So no, I have 8 6 3 2 8 6 3 2, and I want batteries of 9. So in which order to take the smaller batteries? Now that's obviously not true, but it's true also going backwards. That is also not the case, because if I have a6 3 2, then I go backwards, I take 2 3, which is 5, still less than 9, and then I take 6, which is 11, then I have 8, which is not possible, but I could do 8 plus 2 and 6 plus 9. So okay, 15 minutes into. Great. I knew that. I figured it out, but how? Well, what you want to build, right, is n batteries that have lifetime of whatever over k, right? So long L, so they can last 0, and then R is equal to sum divided by N, so they cannot last more than that. L is under R, long return L. And I have some bool OK true. If OK, then L is M, else R is this, so we need to fix the calculation of M. Now OK doesn't work like that. We want to sort, no, this is accumulate battery 0 LL, sort them, right? We want to go backwards and pick the largest ones. So let's say we have batteries 8, 6. We have 2 of these, and then we have 8, 6, 3, 2. The answer should be 9. Should be 9. Okay, well, here it worked, but how would I pair up the batteries? What, you take the smallest number that makes you go over that? What if there isn't such? How many batteries can how to assemble batteries from this? I'm very hungry, so I don't really think. Let's see. I have figured this out in 10 minutes, because I really want to go to sleep soon today. Well, let's say we do max Q, right, of them, and we just take the largest one. We drain it, right, and then let's say we drained all larger ones, and then how do we build? Question is, do we care that we drain? Because if I want 8, let's say I want 9, and there is good question. Yeah, that don't matter, I think. No. Let's say for 9 I would pick this and I would throw 1 back, and then I would pick 1. But that means you cannot use them at the same time. You could use them after. Let's say here I would pick 8 and 6 for the first battery, and that would leave me with 5 extra. But I could only use that afterwards, and I would have 5 for the next battery. I can't figure this out, bro. I can't. Yeah, that's fair. Exactly what happens here. So let's pick the largest battery that isn't in use. Oh, I know. I think I know. So you just pick K largest batteries, and then you try to feed those batteries the rest. Okay, so what that means for us is that we pick all batteries that are, we pick first end batteries, right? So I just do the sorting, I guess. let's do R begin, and then we have the okay, so for int, and then our last, so our pointer 1, which points to the end battery, is equal to this. And pointer 2 is equal to the other batteries, and while pointer 2 is more than equal to n, then we increase it every time. And what we do? Well, we got this sum, right? And we want to distribute it to match it to the previous guy, right? So what will that cost us? Well, long available is 0, and then available plus equals batteries pointer 2, and okay, so this is how much we have available. And so then we have for int pointer 1 is equal to n minus 1, pointer 1 is 0, pointer 1 minus minus. So long if is, let's call it delta batteries pi minus 1 minus batteries pi. So how much would it cost us to increase all the remaining batteries, or increase, so this is just the delta by how much we need to increase all the rest batteries to match the next largest one, because if we cannot do that, then we stop there. So what do we do? Well, that's delta, and then long count is n minus p1, so that is how many are we actually increasing. Okay, and then what do we want to do? So we need this amount, and if we cannot get that, this is ridiculous. So here is what we are gonna do. If available is over delta times count, then available minus equals delta times count, and continue. Otherwise, if we don't have enough money, right, if we don't have enough money, then we want to do return batteries p1 plus available divided by count. So that means that, okay, well, if we don't have enough money for delta times count, then we have available divided by count, enough of money, right? And finally, if available is over 0, then batteries 0 plus equals available divided by n, so we will distribute the rest, and then we return it. pretty easy. But I'm oh my days, what is this? That's weird. So the expected value is way larger. But 5 cases seems like there is just overflow, but I'm not sure where. This is long. 1 LL times this. Can call this long. And let's call this int, and then let's call this long, and maybe that will work. I don't know. Still it doesn't. I'm not. What's the problem? Oh my days. So it is over 0, so what the hell? What is happening? Ah, okay. Now it works. Okay. Where is my? Oh, it's way off. Can we do linear time? Probably not. If extra, what the freak? so stupid. I'm just brain dead absolutely. Sums. Let's use n batteries and try to maximize their last maximize the time they last by redistributing the energy from the rest of the batteries. Approach. Order the batteries by their capacities, energy descending, let's order and let extra available be the energy in the rest of the batteries. To make the computers be to maximize the time of the running time of the computers, we want to maximize the energy of the we want to increase the size, the energy of batteries, so that the energy in the battery with the least energy is maximized. We can do that by first increasing battery n-1 to match the energy level in n-2, which takes energy. If we have that, we subtract it from the available energy and move from n-1 to n-2 and do the same for batteries n-2 and n-3, with the exception of that we now need 2 times this, since now both batteries n-2 and n-1 have to be increased. To increase the running time minimum energy. If we do not have any energy we continue until all batteries have the same energy or we run out of extra energy, i.e. What's that? N minus I battery, N minus I minus 1 minus battery, N minus I is larger than available, then we can only increase the N minus 1 smallest batteries by available divided by N minus 1, which in and the answer is then batteries N minus I minus 1 plus available N minus 1. If we still have an extra energy left after whatever, if we still have extra energy left, after making all batteries have equal energy, we just have to distribute the available energy to all the N batteries. Therefore the answer is batteries 0 plus available divided by N. Time complexity is O N log N. Since we first sort the batteries, decrease in a non-increasing order, and then we iterate through the top N batteries, doing O1 work for each of them. Space complexity is O1 since we do not use any extra memory outside of a few variables. Bye. Have a great time. Good night.